Hi, welcome to this course titled Bayesian Data Analysis for Behavioral Sciences. My name is Himanshu and I'm an assistant professor in the Department of Cognitive Science at IIT Kanpur. So, in this course, you will learn how to do data analysis in the Bayesian framework. So, let's say you have any experimental data from, let's say, an experiment on perception or decision making that you have done, and you have some experimental data, right? So, how do we draw inference about the underlying cognitive process from this data, right? So, um, you need some statistical inference method, right? So, Bayesian inference is one such method. So, for example, you already might know already about frequentist inference methods, for example, a t-test and ANOVA and all that, right? Bayesian inference is another set of methods which actually it's quite different from the frequentist framework, right? So, it's a whole new framework of doing statistical inference. And that's what the goal of this course. So, in the first half of this course, we will conceptually learn how to do statistical inference in the Bayesian framework. And what does that mean? And how do we do Bayesian inference in the uh, uh, on behavioral data, right? And the second half of this course, we will learn how to apply Bayesian inference theory to practice. So, when we have experimental data, then how to do, let's say, regression modeling, hierarchical modeling, linear mixed modeling in the Bayesian framework. And also then to do how do we test a hypothesis, how we test competing theories in the Bayesian framework. Okay. And why do we need this course? Bayesian inference has actually have several advantages over frequentist framework, which you will know as we go along in this course. But just to highlight that it allows you a lot of flexibility in terms of how you want to model the theoretical assumptions that you have about a certain process. You can develop competing Bayesian models about each competing assumption, and you can go ahead with it and you can test theories in a very flexible manner. Second, in certain situations, it's computationally much more doable compared to frequentist LME4, for example, when you want to fit a complex linear mixed model, it is easier to do in the Bayesian framework. And also there are philosophical differences which we will discuss during the course, that how these two approaches view probability. So, depending on the context and depending on the requirement, this is a very useful tool to have in your kit. So, this course is suited for cognitive science students, psycholinguistics students, also for biological science students, and even data science students. It can come handy for all these disciplines, right? So that's it from my side. So that's the intro of the course. I hope you will end up learning a lot in this course, and it would be really useful for you in applications in your area, in analyzing experimental data, and also in modeling in general, in modeling any phenomena. So let's say for data science students, it could be really useful for analyzing data in a different framework. Okay. So, thank you very much, and I look forward to have you in this course. Thank you.